Hey, everybody, and thank you for coming to this week's episode of the Data Intelligence webinar series by Caserta. In this series, we bring you experts from the field, like today, who talk about insightful topics of emerging technology methodologies and other interesting tidbits for us data-driven leaders. So on today's amazing episode, which we're going to kick off, we have invited two great presenters. First, we have James Serra, from Microsoft. James is a data evangelist and big data rock star there who has done so many things I cannot read off a laundry list, but he is the man at Azure to go to. And then we have our very own Brent Walter, who is also a data rock star in his own right. He knows everything about data architecture, data engineering, and would love to chat about it. He is instrumental in helping a lot of our clients with their data architecture and engineering needs and to extract value from their data. So today, the topic is, as most of you already know, migrating to Microsoft Azure. More specifically, how to use it to build a data lake on Azure. What are the benefits? What are the tips and tricks in order to get started faster and to extract the most value that you can from it in the least amount of time? So first, we're going to start with our very own Brent Walter, who's going to deliver a presentation, and then we're going to move on to James, and then we're going to have a 10-minute live Q&A. As always, yes, this will be recorded. I promise I will email it to you after the webinar, and I encourage you all to ask questions in the questions panel on the right to either James or Brent. I shall answer them at the end of the webinar. So let's get started. Brent, take it away.
Great. Thanks very much, Remy, and thanks everyone for joining us this afternoon. So real quick, I'll go through my part of the presentation before I hand it off to James. So I'm going to run through a short history of business analytics and warehouse projects, and that's really just to give us a baseline of what we're up against in the set of problems that we're trying to solve with cloud. Then I'm going to talk about the state of the art in the cloud as far as data warehouse and data lake solutions go. I'm then going to talk about some of the viable options that are out there in the marketplace, and then I'm going to go through some things that we think are really important for clients to look out for when they're selecting a platform or any kind of cloud, cloud software. And then I'll hand it off to James, if you like, to see how Synapse measures up against those requirements, and also how it helps out with some of the process questions that I'm going to go through in my presentation shortly. So I'm going to start right back at the beginning, and this is pre-cloud. And I'm going to paint a picture of what what I'm going to call business analytics 1.0 looks like. And specifically, I'm talking about an implementation project, because that's really the biggest challenge to cloud adoption. It's really getting a project up and off the ground and understanding what the value stream of cloud really looks like once you're there. So a traditional business intelligence, a traditional data warehousing project looks something like this on paper. So we start with our business requirements and we get to value somewhere off at the end. At least hypothetically, this is what it's supposed to look like. I think most people on this call know that it looks something a little more like this. There's about 50 steps. There's a lot more than will be shown on this particular slide. I'll wait for the animation to stop. But the kinds of activities that we find ourselves getting caught up in is a lot of upfront data mapping, a lot of upfront data modeling, a lot of security design, a lot of hardware design, because we're still talking about on-premises, a lot of software selection, hardware selection, costing, business cases, a lot of approval. And this is before we get anywhere near our three goals for our solution, which are really to do analytics, to generate insights, to then help drive value one way or another. So this is what a typical traditional warehouse or on-prem warehouse project would look like. And we know that at the end of this, you never actually get to the analytics part. We usually get stuck with dashboards, and then we get stuck in what I'm calling despair. Which is disappointment with the solution. Disappointment because we've forgotten something. We've left a source out, and it's going to cost an awful lot of money to go back and add a source back into the system, because we've got to start right back at the beginning here and go through all the steps again, resize everything. It's terrible. So I'm going to call this Dante's Inferno of business analytics projects. So we start burning as soon as we get to the security design. By the time we're in procurement, timelines have been overshot. We're really in trouble, and then we get stuck in sourcing, and from there it's just terrible and awful. And we all know that it is totally possible to deliver a successful project on premises, but this is the picture of reality for an awful lot of warehouse projects in the past. And so why do we end up like this? Well, a lot of the reasons for this are technical, but there are also business factors, and sometimes they're tied together. The biggest problem is that traditionally we're dealing with solutions that are bound by space and time. So we're worried about the size of our boxes, we're worried about the size of storage, and we have to adopt patterns that really don't make a lot of sense once these barriers are removed. So that's things like creating hist and snap tables for performance, doing pre-calculated OLAP cubes, storing only portions of the data and getting rid of the stuff that we don't absolutely need. So, and that's really to get around technical factors, and that drives some business factors, right? Because the answer to every question is, well, let's buy a bigger box. Like every time we want another data set, anytime that we want better performance, it's always increment the box, and that requires engaging multiple people, multiple project managers, falling into traditional software development lifecycle processes. And also significant capital expenditure and a need to justify business cases. So what we end up with is a situation where even the most minimal viable product is really expensive to deliver around data analytics. And let's be really clear about what minimum viable means in the context of data analytics. It's just getting data to somewhere where it can be queried without any restrictions, so that you're not hitting a production system, so that you're not bound by databases that were set up and applications that were set up to serve application data. But under these traditional models, the only way to get to that place is to do a full implementation project, which means imagining all the problems that you're going to solve, build your dimensional models, build detailed business requirements, debate the business value, and just drive the dimensional model all the way through. We don't see any value from simply sourcing the data and landing it somewhere where we can get at it with a query engine. So cloud came along and we ended up with what I'm calling Business Analytics 2.0. And here we've got largely the same situation. Don't worry, the rest of these slides are pretty short. I just want to do a big grand setup there. But we lose a couple of things once sort of the first generation of cloud came in, or the first generation of cloud analytics solutions came in. And here I point specifically at Redshift as being a really good example of this. Redshift is essentially a server-bound solution, or at least in its traditional sense, it's a server-bound solution. You're responsible for figuring out and sizing the solution. You're responsible for tweaking it, for managing it on an ongoing basis. And so we end up with a lot of the same problems that we have on-prem. Sure, there are certain things that we get rid of, like our hardware procurement's already done, so there are no delays from that. We just go and we spin it up. If we need to expand it, we can just go and we can expand the cluster. But there are some problems with that. And fundamentally, these solutions are still bound by space and time. It's just that we've moved our problems to somebody else's hardware. Handling large amounts of data in these situations requires reconfiguring the cluster. It means scaling up is usually easy. You've got to get a DBA to do it though. Scaling it down is an absolute disaster. And you can only handle flat data, right? So traditional tabular based data. And our MVP is still a really expensive proposition because we've got to go all the way through to dimensional models again. So then we come to what I'm calling Cloud Analytics 3.0, and the best example of this is probably Google's BigQuery, or at least BigQuery when it was first released. And here we move away from thinking about iron and thinking about the size of our servers and things like that, and we focus more on a service. So here it's a query engine that gives us the ability to do an awful lot of stuff just by landing data in places. But notice that the process looks the same. You know, we've got less hot areas that we need to focus on. Sourcing is still a problem, but we're still doing this full development cycle. And we've got to ask ourselves why we end up doing that, even though we've got tools now that we don't have to do this with. And the reason is that we need to sort of identify where the sources of the problems really are. And those problems are largely on the business side, right? It's things like gathering the business requirements, building all of the technical requirements. These things become bottlenecks to a lot of cloud migration projects. And these are all really important subjects. It's just that they're in the wrong place. So activities like business requirements, use cases, your bus matrices, building your data mapping and your data modeling, you should be doing that and worrying about that after you've got data in the cloud. Because data, once it's in the cloud, you can query it. You can start milking data from it. You can start milking value from it on day one. You can delay a lot of these steps. But we see frequently clients coming to data warehouse projects with this mindset that we've got to think in dimensional models. We've got to get all the way to a fully baked and designed design of a data model before we can start moving data into the cloud and before we can start seeing value. And I want to challenge that because I don't think that that's true. Because the truth is that I've just said all of this. So I want to challenge that with this model, because the fact is that a lot of these problems of space and time, and the technical constraints are gone in the cloud, and we really need to adopt different ways of doing things. So instead, I want us to think about starting a lot of these projects with sourcing alone being the name of the game, or at least being its own value stream. And here, the idea is simply to get the data from source and land it in the lake, because once it's in a lake, we can put an access engine on top of it. So that would be a BigQuery, a Synapse, that'd be a Snowflake, whatever it is. You can stick an access engine on the top of it. Then you can do your analytics. You can get some immediate insight and some immediate value. And those insights can drive further business requirements and further things that you might need in your environment. So we end up with a virtuous circle and a big happy face in the middle of it. So why do we want to do this? Well, it's leveraging cloud the way that cloud is meant to be leveraged. It's looking to use the full capabilities of the tooling from day one. It's about treating sourcing as the only problem that we need to solve, first of all, and then worrying about modeling and all of the other traditional processes that are involved in a data warehousing process. We should start by thinking about how much, of total data that we want to onboard, and then we need to prioritize and be guided by marginal cost and expected benefits, rather than seeing our sort of our dimensional models as the end goal and how we measure value in the solution. And one of the ways that we can get to this mindset is by treating data as an asset and sort of running these kind of streams or running these kind of patterns rather than trying to imagine what the value is at the end of the day. Adopting a data management strategy, manage data as an asset strategy that can provide the justification for landing the data in the cloud, which would then give your analytics team the ability to have at it. So what's the real magic that allows us to do these kind of things in cloud? Well, it's all tied up in the access engine or the presence of the access engine. The access engine gives us elastic compute, elastic storage, low to no ops, depending on the solution, and security baked in. And this last point, security, is something that I'll focus on in a slide's time. So out in the market, what are the options that we've got? Well, we've got Snowflake, which has been around for a time now and is exceedingly popular. We've got BigQuery, which is really the granddaddy of a lot of these solutions and is going through its sort of latest evolution. Then we've got Synapse, which is going to be James's topic in a little bit, and it's a super exciting product for a lot of reasons that'll become clear in the next couple of slides. We've got solutions like Databricks Delta, which is a Spark-based solution. We've got various offerings on AWS that could be combined together to deliver something like this, but it's a fairly complicated road to start down. And then we've got other newer entrants to the marketplace, like Action's Avalanche product, which has some interesting characteristics. And of course, you've got the option to roll your own. So a lot of these technologies are based on open source components, and you could feasibly design your own solution. Although if you do that, your maintenance burden is really high. So what are the key considerations? Well, let's talk about security first of all. What you want from one of these solutions is something that will integrate directly with the platform identity and access management system. And the reason that you want that is that it simplifies the security footprint. Some solutions like BigQuery and Synapse do this really well. Other solutions have excellent security, don't get me wrong, but that security is separate to the way that you're managing the rest of your cloud environment. It should also support table and object level permissions, and just about all of the solutions do this. It should also provide some ability to control access to columns, like individual columns of data, without interrupting user queries. And it should provide some ability to enforce row level permissions. And we know that there are ways to do this with views and sort of traditional modeling techniques. But ideally, you want these things to be expressed in purpose-built security mechanisms that are kind of abstract to the rest of your analytics products and your design and your ETL. You really want these things enforced by a security subsystem. And more importantly, you want parity across access mechanisms. So we know now that users aren't just getting at data through an SQL interface. They might be coming in using R. They might be coming in using tools that are interacting directly with objects in the lake. And we really want a situation where we're able to apply our security in a more or less level way across all of the different mechanisms that users are using to access the data. So I am missing a slide, believe it or not. Yeah, I'm missing a slide. So I had some other info here, or some other considerations here that were going to be around things like cost and looking at the ability for the solution to deliver you options around the way that you handle burst computing and the way that you handle automatic scale up and down. So Remy, I'll make sure that the copy that we send out to people afterwards includes that slide.
No worries.
But I guess I'll hand it over to James now to tell us how Synapse measures up against some of these requirements and solutions, and how that solution can really help us out. So James, I'll hand it over to you.
Awesome. Brent, thank you very much. James, do you want us to jump into questions? Do you want to give us briefly to answer Brent's how does Synapse measure up, and then we can jump into the other questions we prepared.
Yeah, I'll just give a brief overview of what Synapse is, because many of you may not be familiar with it, and then we can jump into questions, and I can pull up a couple of nice pictures of Synapse. But the challenge, and I agree with everything Brent said, is with customers is the first thing they should do is get the data in the cloud. And that in itself could be problematic. There's issues with security and data governance and putting things in the cloud and they're not sure where it should land, and PII information, all like that. So I have a lot of conversations with customers just on how to set up the data lake in there. But all of my customers that I deal with are going to the data lake, and it's because it's schema on read means I can land anything in there. And that's the first step that I tell them is, let's get everything in the cloud, let's put it in the data lake, and then we can start making better business decisions by pulling the data out of there. Now that's where it gets a little more complex, because it may just be a bunch of Parquet or CSV files in there. And depending on the skill set of the customer, can they pull that data out and make it useful? Well, that's where Synapse has come into play, where we've taken the combination of a data lake and a data warehouse, and you may hear this new term called data lakehouse, where we sort of blur the lines between, does data have to be in both a relational database and in the data lake, or can it be in one? And now with this product, it sort of gives you the choice of landing it in either one of those, but using T-SQL over the data, no matter where it sits. So if it's in a relational database, or in a data lake, I can use T-SQL to access that. And that opens the door for any other products to go and use it if they support T-SQL. So I can very quickly and easily use a product like Power BI to pull data out of a data lake and see if it has value or create a one-time report. But we've come a long way now and try to make it easier once this data lands in a data lake to make use of it. And that's where it's blending both those worlds of the data lake and the relational database in there. So there's a lot to that product, and it's become extremely popular with customers because it's really the future of where we're going to try to make that access of the data so much easier. Now, when you throw in data that's from IoT devices and social media data, all this data is great, and we want more of it, but it was frequently a problem to merge all that data together to clean it and then present that. And now you don't have to be an IT person to do all those kind of things with some of the products we have now. So that was my quick overview of Synapse.
And that's an excellent differentiator, as Brent is very excited about. We've heard him speak about it internally many times. So let's jump into some questions that I think people are curious about for Azure. Firstly, can you share with us some of the technical and business considerations? Like, why would an organization choose for a given use case to go to Azure? And on top of that, what are some features or functionalities that get you really excited? I mean, Synapse being one of them.
Sure, and the customers I deal with, all different industries, all different size customers, everybody's going to the cloud. There's many reasons for that, and it's not just cost. It could be things as the ability to get a project started quicker compared to on-prem, and I was a DBA for many years and went through the pain of trying to order servers and racking them and stacking them and getting them all provisioned, which takes weeks or months. Now I go to the cloud, I click a button, and within a couple of minutes, I have my whole environment. So how do you put that to a cost? You can't. It's an indirect cost that you're saving on there, but there's many things like that come around with unlimited storage and automatic updating of the operating system and the software and all these things that were real pain to do on-prem. Now you don't have to do them anymore. So customers, the conversation's changed. When I first started at Microsoft 6 years ago, we had to convince people to move to the cloud. Now it's sort of a no-brainer, especially when they become familiar with the security and how much more of it is in the cloud, and you have less risk, you have high availability built in, disaster recovery. All these things make the cloud so much better. And when it comes to cost, because you can pay as you go and you can scale products up and down or just get rid of them, it makes it much more cost effective. So the conversation has changed with, okay, all these products in the cloud, which one's the best to use? And that's where I spend a lot of time as an architect, because there's many different ways to go about solving a problem. It's choosing the right tool. And I have to ask them a lot of questions and sort of narrow it down on what's the best approach to take when they're looking at building something in the cloud.
Sure. And speaking of the best approach,
can I nerd out there just
nerd
out? So I think probably one of the most exciting things about Azure is if you're a site that's fully embraced PowerShell, you've got all of the PowerShell management features and automations available to you, and you can even deploy it to use as Lambda functions. It's pretty awesome, and if you're not using PowerShell already, please go out, use it. It's great. But Remy, just to answer your point or your question about specific use cases and sort of where a solution like Azure really sort of comes to the fore, and particularly the features and the security features around Synapse, I think financial services and healthcare are two massive areas where there's always that need to enforce individual access to particular data attributes and to control who has access to what records. And the ability to be able to do that across different parts of your data ecosystem is just magic. The security features that are available in Azure are absolutely top notch for this particular class of solution.
Yeah, that's great for HIPAA requirements and functionality there. That's excellent. So I'm going to move now to another question, and Brent touched about this. Landing your data in a data lake. Now, according to, and this is a dirty word, and you even mentioned a data lake house, because according to Gartner, 85% of data lakes fail, and they don't meet the requirements or the expectations of those who architect those data lakes. So how is Azure going to help here? And is it different? And are you, and Brent, please chime in on this, are there any recommendations of how you can make sure your data lake does not fail on Azure or in general on the cloud?
Well, I'll start it off. And when I get that question from customers, for companies, it's not so much a technology discussion, but a people and process. What are you doing to put these things in place? And surprisingly, a lot of customers come to me and they want to know not so much about the technology, but how are other companies doing it? How are they building out their teams? What are the people in the process they are putting in place? What should their roles and responsibilities be? And so that was interesting. And I have a lot of experience with all these customers because I see them day in, day out, and find out through discovery how they are doing things. And then you come up with, oh, these are great ideas that some of these companies are doing, and then you share them among the other customers in there. So when you look at the data lake, why they fell, it could be some of the problems early on where people thought I can dump everything in a data lake and it's this magical world of fairies and unicorns and everything comes out. And I have some horror stories of people who failed miserably because they thought things were going to be easier putting them in a data lake. Oh, schema on read, I just dump stuff in there. Well, it makes things more difficult because it's easier to dump something in there you shouldn't. It's more challenging to get the speed out of that. Compare that to relational database, which has got index and statistics and query plans and all these other things that are not in the data lake. So customers were seeing it was slower, it was sort of a free-for-all. And to land something in a data lake and go to a customer, an end user who's could be an auto mechanic who doesn't know anything about IT, and say, oh, your data's in a data lake, go use Spark and a Hive query and fire up a cluster and you'll get all your data. It's in CSV files out there. No, it's not going to work. And that's where a product like Synapse come a long way, and you can now put data in a data lake and it's schema on read, but you have to pay the piper, and that means you have to understand the data when you pull it out. And we've made it easier to put metadata over that data, but you have to understand how to organize all that. So our conversations become, how do I set up a data lake? What are the different layers? How should I set up the folder structure? How should I set up the security on there? What tools should I give you access to? What should they instead maybe use the relational database? And what Brent brought up before, you need to have, the other thing about the relational database is got row level security, column level security. So it's got a lot more features in there that you can put on top of it to make it easier for end users to pull out and not see something that they shouldn't.
So if I can just chime in there for just the one word that James hasn't mentioned, but he's alluding to, and that is data governance. The way that you stop your data lake project from becoming a disaster is probably by not looking at it as a data lake project. The technology is not that important. The technology is there in the cloud, in your platform. That technical part isn't something that you got to worry about. What you do need to worry about is making sure that you've got the processes in place and the automated processes in place to alert you when new data lands, to make sure that that data has been entered into a catalog, to understand that the data has an owner or a steward, and that the data is maintained, that it hasn't just been dumped there. So in other words, we should approach a data lake project as an information project more than a technical implementation.
Yeah, it's an excellent point. And Brent, are there any recommendations from some Caserta clients you could give us of things that you learned, or any catalogs that have been put in place that you can say where that was added value to help there? Yeah, so look, there's a lot of really great data governance tools that are out there, and it really depends on the specific objectives that you're looking to achieve. So some of the tools have a really strong social element to them, and that's great if you're trying to crowdsource information about the data that you have, and so Elation is a really great tool there. Other tools are much more geared at controlling the business processes around data governance, and that's where
that's where you get into your Calibra tools. And other tools focus much more on the quality control aspects of data governance and allow you to interdict. And a lot of the Talon solutions come in there, and we've seen a lot of success with those.
Okay, excellent. So then building on that, what are some of the technical challenges of ingesting data from many different sources and different formats? And how do you solve this with respect to Azure?
Yeah, with customers, their data is everywhere. I had a customer today, I still had data on mainframes. And you have data that's either, could be on-prem, it could be in the cloud, it could be in various different formats. It could be in all different type of, not only Microsoft products, but all various other companies' products in there. And hey, we want to get this in the data lake and we want to do it quickly in there. So this is where products have evolved, and we have the Azure Data Factory, which has come a really long way in being an orchestration tool and a data cleaning tool. And it's got over 100 different connections to all these different data sources. And we have a wizard in there, a copy wizard, so it makes it very easy to go in there and say, this is my source system. It's a, say, on-prem SQL, and I want to lend it into my data lake in Azure, and go and build it out. You enter the connection information, and it pulls it out, and it does it very quickly. So that's become very popular. It's more of an IT-centered product to pull that data out in there. And then we also have Power BI, which has underneath a feature called data flows in there, which I call it self-service ETL. It allows end users to go and use those same connections to pull data from a source system, and then use a feature called Power Query that a lot of customers are already familiar with, that can clean the data and land it into a data lake. So they become an end user with a little bit of knowledge can go and pull the data themselves. And so you have two different options for customers. And I've seen a lot of customers focus, if they're on the business side and using the Power BI data flows, and IT side using Data Factory. And we have a way to sort of meld those products together, which I talk to customers, and so they're not wasting the effort. But it also opens up the door for a benefit where instead of IT having to go to the end user and say, okay, do you want me to build a report for you? Okay, give me the business requirements. And then you go back and you build something, you give it to them, and they go, that's not what I wanted, that's not what I meant. I did that for many years. Now with a product like Power BI, they can do the prototyping. They can go, because the tool's easy, and they could build the report and say, this is what I want. Look, I built it. And then IT could take it over, but they've done all the work for you, and they know the data the best, so you left the guesswork out of it on your end, and they can use that tool to because it's so easy to generate that prototype of the report.
Yeah, just on sourcing. Sourcing is it's the classic problem of any data project, and there is no one silver bullet. But what the cloud does give you, and this is any cloud provider, Azure included, is the ability to use techniques that are just not available to you on-prem. So if you do have particularly problematic sources, say for example, they're from some legacy application, and the only way to get at that data is to write some crazy thing that goes and does screen scraping or something like that, you've got the ability to port the data, port the entire application in its database over into Azure, and then spin up that same application, provided that it's a supported platform, of course, but spin up that application and build out the infrastructure that you need to do just those extraction jobs, and then spin it down and get rid of it at the end of the day once you're done. So there's always a solution out there. What you've got to be really mindful of is the size of the data, how frequently the data is changing, and ultimately, what is the type of source? So if it is mainframe, well, you're going to be in for some fun.
So just to clarify, I'm going to take one step back because we have an audience question that's pretty pertinent. He writes, I hear the term data lake being used a lot in different contexts, as an initial landing area for data in the cloud, as a storage product in Azure, where data can be loaded with or without a model. Microsoft uses the common data model. How do you view the process of landing data into a data lake and then gradually implementing a model?
Yeah, I tell customers a data lake is nothing more than a glorified file folder. So you have to go up front and design something that's going to make it easier to use. And that involves creating an architecture, layers, folder structure, security, all those things come into place. So it's great because I can just land that data in there very easily. And there's various ways to get data on-prem into the cloud. And as Brent said, depends on the size and the type. There's different mechanisms, and Data Factory can be used for a lot of that. Once you land it in there, well, it's just CSV or Parquet files. Well, what are you going to do with them? Who knows what those are? So this is where it comes in roles and responsibilities. You have to have a data modeler, somebody who really understands that data in there, and they know how to clean it, they know how to join it, they know how to master it. And then what we see now is that person will build a data set that's essentially a data model on top of that data, and then allow others in Power BI to go and say, oh, the data set's out there, I will build a report off that, but somebody's done all that work to put it together. Now, that could mean in a data lake, they land it into a raw layer, and then they clean it, and they then put it into a clean layer, and then a presentation layer. So there's a lot they can do with it, and then they may move it to relational databases. And so somebody's got to do all that work. Well, the good thing is if you design it right, somebody does that work, and only one person does that work, and then everybody else can reuse the work they've done. But that's a people and process that's got to be put in there, and have that data governance, and just the ability to take and let people know that these data sets exist. It could be a challenge on there. So I talked to a lot of customers about the best way to do that and using our technology. But once you set that up, you talk about self-service BI. Customers can just go into Power BI, they see the data set, and within moments they're creating reports, very sophisticated reports, because somebody did all the modeling for them.
So for my money, when we're talking about lake strategies, and I agree, lake can really easily become a dirty word, but the name of the game, I think, is getting control over the sources of data and getting that part of the lake really well organized by source name, possibly by source type. But don't try and add things like subject areas over the top of those sources, because you don't know how you're going to use that data in the future. But that's going to be your source of anything that you do downstream. After that, I think that you're always going to run a risk of ending up with something that's disorganized. So it's just important to be mindful and be minimal at all times throughout the development of your lake. I think that most lake designs, most software designs, frankly, fail because you try to do too much too soon up front and try to predict what your needs are going to be 6 months down the track, or 2 years down the track, when the decisions that you make now that cover you for the next 6 months are easy to back out and revise and sort of change as you go along, if you haven't adopted some grand design.
That's an excellent point. Yeah, I think we've seen it with a lot of our clients that have come to us with problems that they've just tried to boil the ocean, and that's one huge reason why, or try to boil the lake, and that's why it fails. So I've been hearing a lot about hybrid and multi-cloud strategies, either on-prem or with other clouds. Can you share with us a little bit more about these strategies, and how do they fit into a data ecosystem strategy in an organization? And how does Azure fit into the mix?
Yeah, well, hybrids, everybody's doing hybrid. No customer comes in and say, we have all these databases, we want to flip a switch and have everything in the cloud at once. So it's a progression. And sort of Brent's point is you want quick wins. So I'm not going to say go and move all your data into the cloud and then rearrange it, put it in a data lake, put it in a relational database, and then run reports. What can we do that we can do quickly to get a quick win and show the value of moving to the cloud, and then open up these budgets from your company to do more with it? So in the meantime, you're going to say, well, let me do something quick in there. And so I'll have a hybrid approach. And so I'll move some of the data in the cloud. Or a lot of times customers will say, well, we want to make use of IoT data or social media data. Well, we can't put this on-prem. We don't have the horsepower. So we'll start building a data warehouse, and we'll use these new sources, maybe combine it with a couple of ones on-prem. And because Microsoft has software and legacy and on-prem, we have all these products on-prem, and then we have the cloud, and they all integrate very well. But even with competing products and competing clouds and other on-prem systems, we're all interfaced that. Microsoft's changed a lot in the 6 years I've been there to try to be able to easily match up this data, even if it's not one of our technologies in there. And when you look at a product like a Data Factory, we have these things where you can create a data gateway that allows, for security reasons, to get data that's on-prem and then pull it up and then incrementally refresh it. So you have this hybrid approach where I can keep some of the data on-prem and have other data that's born in the cloud. But it always becomes an important topic with customers is what do you move? What are you planning on moving? If you have an app that's on-prem and a database on-prem, you don't want to move one without the other into the cloud. So let's work on moving both at the same time and such in there. So it's just asking customer questions and finding out what their ultimate goal is, and then taking steps so they can get a quick win, but then have a large overview and architecture of what it's going to look like at the end.
Yeah, hybrids really very much an evolving and a moving target, both in terms of what we mean and what we're trying to achieve with our hybrid strategy. But I think that's actually the key to it. It's understanding what you want to get out of your hybrid strategy. If you see yourself in a situation where your longer term goal is to get everything off-prem and get everything into cloud, you don't really have a hybrid strategy. You've got a long-term migration strategy that you're running. It just happens that you're falling back into maybe some hybrid patterns in the meantime. But if we're talking about longer term issues, so say for example you've got some jurisdictional issues around particular data sources or particular applications that require you to maintain custody over those applications. The strategy there really needs to be around solid data APIs and solid APIs that really control the access to data, and also systems that disclose to each other the purpose for wanting to access the data, so that rules around processing and whatnot can be enforced. Again, there's no silver bullet here. It's a lot of hard work and a lot of design work that needs to be done. I'll just throw one other thing. If you are an organization and you're thinking about pursuing a hybrid strategy, one thing to get right up front is making some decisions around your approach to identity management, because identity management across environments and particularly across cloud providers back onto your on-prem, it can be a real challenge if it's not done properly.
Sorry, excellent points. I'm actually going to take a question from the audience, and this is back to ingestion and actually master data management. So she asks, assuming when we were referencing getting data to the cloud, the company already has a handle on MDM and a solution for metadata management. So is your approach the same if a company is at the beginning and only has a relational database copied over into an ODS and then pulling from there via data flows in Power BI?
Yeah, it's tough to answer some of those questions without going into a lot of inquisitive of how their current environment set up in there. But I will say that although at a high level, I tell customers they have to ingest the data, land it, transform it, model it, and then visualize it. The way they go about that could be very different between customers. Even within a customer, it can be very different depending on the data, the size and the speed and the type of that. So there's no one standard answer. I wish there was, and make my life a lot easier, but it's always that it depends on there. So with customers, I have to look at what do they have in place. I'm not going to, there's always that balance too between what's their current skill set and what are their certain licensing and all these things that can go into the solution I'm going to recommend to them. And if they have something with master data, that's great, because most customers don't even think about master data, unfortunately. But then I would say, well, how can I work in a solution in the cloud with that current master data management? And really, that's just mastering just comes another layer, maybe in the data lake or in your relational database, to take that raw data, clean it, and then master it, and then present it. And I always tell customers, when you're designing a project for building a data warehouse, have on that timeline a lot of time to clean the data. Because when I was a consultant, customers were like, my data's clean, it's great. And I'd always say, I'll bet you $100 right now, we're going to find problems. And you find that the birth dates in the future, or people are 200 years old, and there was problems in the source system that they went around and all that. So you have to put a lot of time to clean the data, and then you have to spend a lot of time mastering the data, because the last thing you want to do is come out with a report and you give it to the end users, and they look at it and they go, this data is not right. Why do you have somebody in there twice? And right away, you're lost their confidence. So you have to spend the time up front, so you're not in that situation where they don't even trust anything that you're putting out in the future in there, and mastering becomes a big part of that.
Brent, did you have anything you want to add?
Yeah, I think if you're a customer who's got a great handle over the data and you've got data that's already mastered, if the question is it legitimate to consider cloud as just an endpoint for that data and just a landing point for that data so that you can access better tools? Absolutely. If you're happy with your environment, you're happy with your cost profile, 100% we'd support you. I think if the question is, we're doing some mastering on-prem at the moment. We want to do some stuff in the cloud as well, and that's going to be sourcing from different data sources, and we want to integrate those mastering processes together in some way. That's something that we'd need to dive into in a lot of depth. But I think the first question that I'd ask is, what does your license look like?
Yeah.
That's a good point. So I'm going to move on to an audience question now that was asked. And this is kind of like expanding upon Brent's awesome build-up in the beginning. So she says, Brent presented us a diagram of a complex and traditional way to build a data warehouse, which often fails. He then simplified it. And then James is presenting a new way, which involves people, processes, and data governance. I guess both of you were presenting that. And then she asks, so what does this new model look like? It doesn't sound like you could just dump data into the data lake like it seemed like Brent was suggesting at the beginning. Is there a quick way to approach this? And can you give maybe a process map and some examples? I don't know if you have anything ready for a process map, but perhaps you can give some examples.
Well, if I could just volunteer one thing just to make sure that I was absolutely clear. My argument wasn't that you just go and dump data into a data lake and that you're done. That's absolutely not my contention. My contention is simply that you can approach the design of dimensional models and all the traditional things that you would do around warehousing and even data lake organization as its own set of work streams that don't have to be incorporated into sort of like that don't have to be incorporated into one long enterprise project. That if you're wanting to get started out in the cloud, the biggest bang for buck that you get getting started in the cloud is just having data that's there that you can analyze. And once you've got the data there available to analyze, then you're able to build on that data at will. So basically, you can have your project running to build out your enterprise data warehouse and all of the good stuff that comes along with the data warehousing project and data warehousing approaches. But at the same time, while that's going on, you've still got analytics users that can be milking value from the data simply because it's there and you've got powerful tools to look at that data.
That's an interesting approach. I mean, many CIO and data leaders, they're mandated with just migrating to the cloud immediately, and they start with a lift and shift, which usually we speak out against. But this sounds like you're advocating we should put data immediately on the cloud without re-architecting this data strategy. Could you clarify that? And what are your thoughts on lift and shift in general? Is there ever an appropriate time to do it? And how would that fit into what you're saying?
Yeah, no. This is by no means lift and shift. This is just how to start out and how to think about the way that you approach the project. What we're trying to get away from are really long-running enterprise projects that take years before they deliver value to any stakeholder. What you want to get to a point of is being able to deliver minimum viable product. And to be perfectly honest, any strategy that you start out with, any strategy that involves cloud and involves that involves bringing data into the cloud, starts with that sourcing, starts with making data available to users, and that process should be absolutely robust, and it should be economical to onboard new sources at will, and a lot of effort should be placed on designing just that process rather than getting too tied up with what the dimensional model is going to look like in 3 years.
Excellent. James, did you want to chime in on that last point?
Yeah, and I agree with everything you said. And I'm just going to show one slide because I worked on this all morning,
Please.
so I have to show it off.
Please do.
And let me know if you can see this.
Yes.
Yeah, so this is Synapse, and this is a high level of the products we have within under one roof. We call it Synapse Studio. And at the top here is Azure Data Factory. So this is the orchestration tool to pull that data in. And then over here, you'll see the data lake, and this is where all the data is going to land initially. And once it lands in this data lake, it's what we talked before, just get the data in there. Well, how can you get value out of this data? And now we have multiple ways of querying that data. So we have the provision SQL pool, which is like SQL Data Warehouse was. We have an on-demand pool that's new, and we have a Spark provision pool. So as a customer can land this data in the data lake, and the struggle before was what tools can I use to pull it out? And it was sometimes difficult to use some of those tools. Now, what I highlighted here is T-SQL could be used, and I could use an on-demand pool. So the idea is I could go and put data in the data lake, and I can write T-SQL. Maybe it's a view on top of that data in the data lake, and then I can start write queries on that. I can use Power BI as that query tool. So I'm not having to provision anything, and it's on demand, so I'm only paying when the queries run. And I'm actually pulling data out of a data lake, but it's regular SQL. So the end user will likely think it's in a relational database when it's actually not. So this opens up a lot of possibilities of quickly seeing what the data is. You can, in this product, you can literally right click a CSV, a JSON, or a Parquet file and say select top 100 rows, and it pulls it up. And I don't have to do anything else. It generates a SQL for you, and you get your answer right away on there. So I can investigate. I can also do that for one-time queries or for reporting on there. So we try to make it a lot easier. Now, we've made it easier. We have a lot of options on here, but you still have to have that data governance in place. You still have the people and the process in place. So while the tools have made it easier on there, that doesn't shortcut the process of putting those procedures in place.
Absolutely.
And that's my beautiful slide I spent all day on.
Thank you for that. And that's an excellent point. At Caserta, we often say to most of our clients, it's not just the technology, it's the people and the processes that are the most important. And just like Brent said, why did these data lakes fail? 85% is a staggering figure. The answer is they didn't adopt it right. They didn't have the business requirements right, and the processes weren't right. The technology was fine. So
yeah, and I'll just add to
is
that.
something we always work on. Yeah.
Yeah, and I'll add to that. I'm not trying to. Well, when customers come in, and if I find that they have never built something like this before, I start asking them about partners and bringing somebody who's done it before. And that's where it's extremely valuable. The customers, why that number is probably so high is because somebody thought, well, we can figure this all out, and they go and do it, and then it fails. Well, why not get somebody in there who's done this many times, who's familiar with all the products, and can build it out? So when they come to me, I help them architect it out, but then I tell them, well, who's going to go and build this? And if they come back and say, we're going to do it, we've never done it before, I'm going to say, well, wait a minute. I don't want to see you fail, so let's get some help, whether it's a partner or somebody internal in Microsoft in there. So they'll get those people who have experience on there, so you make sure you're going down the right path and it's done the right way.
Yeah. Well, and on that point, anyone who has any questions about data governance and implementing a data lake on Azure, or even talking to someone to validate your opinion, we know you guys are rock stars, but let's build together. Let's validate your opinions. Talk to us. We know you're the best, but sometimes you got to pull over and ask for directions in a pre-GPS world, right? So that's where Caserta really shines. We have the strategy to tell you maybe what you're doing isn't the best idea. Let's point you slightly in a different direction. Let's validate your assumptions before you're just working on a project that's fixing a toaster on the Titanic. So thank you both for your time today. I think we all learned a little bit more about Azure and Synapse and how data governance plays a really key role in building these data lakes and other data ecosystems on Azure and other clouds. Thank you to the audience. If you have any further questions and any questions I didn't get to, please email them to me, remy@caserta.com, and I shall get a great answer for you. We will be emailing you with the recording of the presentation as soon as I process it. All right, everyone. Thank you so much. Bye, guys.